This video is going to be our last video for this year. In this video we are going to make a quick revision for all the things that we have taken throughout semester 4, and you are going to solve our exam review worksheet, okay? The first thing I'm going to start by is the diagonals of quadrilaterals. I'm going to construct quadrilaterals based on their diagonals. So you have to always memorize that the diagonals of the parallelogram intersect in their midpoint, or in another word, they bisect each other. Okay? For example, if you have two straight lines that meet at the same midpoint, or this point is the midpoint of both lines, if you just join the points, you will find that this is a parallelogram. Okay, and you have to know that the diagonals of a rectangle intersect at their midpoint, but they also have the same length. The diagonals of the diamond or the rhombus, in another word, they bisect each other, but they are also perpendicular. And the diagonals of the square, they intersect each other, they have the same length, and they are also perpendicular. Now we are going to learn how to draw those quadrilaterals. First, I'm going to draw, for example, a straight line AB, which is 6 centimeters long. I'm going to search for its midpoint. And then I'm going to draw another line, suppose it's CD, and this point that I draw, O, is also the midpoint of this line CD. But they don't have the same length, AB and CD. If you just join the points, you will find that this is a parallelogram. The second thing, I'm going to draw also a straight line AB, and I'm going to search for its midpoint, and I'm going to draw another line CD, but with the same length, or in another word, AB is equal to CD. So they bisect each other and they are equal. If you just join the points, you will find that this is a rectangle. So every time you are going to draw a rectangle, you should draw two lines that bisect each other and they are equal. If they are only bisecting each other, it's a parallelogram. Now if you draw a straight line AB and you draw another line, this is AB. Okay, draw another line CD with the same length and perpendicular. So now I have diagonals bisecting each other, perpendicular and equal. They will form a square. The difference between a square and a rhombus is that those two lines, they are not equal, but they are perpendicular. So if they are not equal, it will be a rhombus. If they are equal, they will form a square. Now let us solve this exercise, which is found in the exam review worksheet. In which quadrilateral the diagonals are congruent, or in another word, equal? The diagonals are equal in the rectangle and in the square. Diagonals bisect each other are in all the quadrilaterals. Diagonals are perpendicular, it's only in the square and rhombus. That's how you are going to study them, okay? In this exercise, I'm going to calculate mentally the following. If I have times 1000, I have to move the point 3 digits to the right. So I will get 1, 2, 2, 1 and 2 zeros, because every empty place is filled with 0. Times 100, the same concept, I will get 62. Now divide by 1000, I pretend that there is a point and I'm going to go backward 3 digits. Every empty place is filled with 0, so it's 0.019. Now divide 100, the same thing, the point is here, so it's 0.081. Now I have different thing. I have divided by 0.01. I can divide by 0.001, so I change the division into multiplication, and then instead of having 0.001, it's 1000 with the same number of zeros. So I will move the point now 3 digits to the right, so it will be 100. The same thing, I'm going to convert the division into times, and instead of 0.01, I will put 100, so it will be 472. And here the same, I'm going to convert the times in the division, divided by 10, so I move it backwards, so it's 0.339. Now divide by 10, I move it backwards, so it's 5.56. In the multiplication of decimal numbers, you don't line up the factors by the decimal. Always remember, you shouldn't line them up according to the decimal point as we do in the addition and subtraction of decimal numbers. Instead, you only place the number with more digits on top, you line up the other number underneath at the right, and then you multiply. After you multiply, you pretend as if there is no point, then you count the number of decimal numbers in each number, and then use the total number of decimal places to move your point in your product. Let us do this exercise, this example. I have 5.63. I will take it times 7. Okay, 7 times 3 is 21, 7 times 6 42, plus 1 is 43, 7 times 5 is 35, plus 4 is 39. Now I count how many digits do I have in the decimal part. I have two numbers, so I move the point 1 and this is 2. Okay, and now let us do this 5.4 times 7. So as I told you, it's not important to put the point or to place the point under each other. 7 times 4 is 28, 7 times 5 is 35, plus 2 37. And the point, because I have only one digit, so it's 37.8. I'm going to do the last one. 1.23 times 0.002. So no need to place the point under the point. 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2. No need to multiply the zeros because they will not make a difference in multiplication. Now let us count how many points I have in the decimal part. I have 5. So I have to move 1, 2, 3, 4, 5. The point is here. So I have two zeros, so it's 0.00246. Okay? Now we are going to revise the division steps. Okay? Solving a division is step-by-step process. I told you to always remember that mother, sister, brother, they indicate D is for divide, M, multiply, subtract, and bring down. I'm going to take an example. Suppose I have 732 divided by 4. Okay? The first thing I have to do is to divide. I take the 7, which is one digit, and I divide. 7 divided by 4 is 1. Now after dividing, I multiply. 1 times 4 is 4. After multiply, I subtract. After subtraction, I bring down, and I do the process all over again. Divide. 33 divided by 4 is 8. 8 times 4 is 32. I subtract, then bring down. The same steps all over again. 3 times 4, 12, and the division is done. Now let us perform this division. I'm going to start by the first one. I have 487.2 divided by 8. I start multiplying. 0, 4, now 48. It's what? 6 times 8, it's 48, and I subtract. I place the 7, 0. 0 times 8 is 0, and I subtract is 7. Now every time I reach the point, I just put it in the quotient, and then I bring down normally, and now 9 times 8 is 72. The division stops, so it's 60.9. Okay, now let us do the second one. In the second one, I can divide if I have a decimal number and the divisor. So I need to get rid of this point. How? By multiplying by 10. Because 3.2 times 10 is 32. I can't do this unless I multiply also the dividend by 10. So it becomes 9,724. Okay, now I can perform the division normally. Let us do it by 10. So 9 times 10 is 90. 7, I bring down the 2. Also 7 here, 2 down. 4. Now 2 times 10 is 20. And I have 4. Now I place the point and the 0. What's the number you multiplied by 10 to get 40 is 4. And the division is done. The same thing I'm going to do in the last one. I can divide if I have a decimal point in the divisor, so I have to get rid of this point by multiplying by 1000. If you multiply by 1000, now I have 4. And one condition, if I also multiply the dividend by 1000, so I have 5360 divided by 4, and I do the division until I have a decimal quotient. Okay? Now we are going to learn how to change from mixed number into improper fraction and vice. For example, if I have 13 over 4, you know that this number is an improper fraction. Let us divide this number. 13 divided by 4, it's 3. 3 times 4 is 12, and we subtract, it's 1. So this fraction is written as 3 and 1 over 4. Okay, so if you want to change from an improper fraction into mixed number, you have to do the operation of division. Now if you want to do the vice, which is, for example, suppose I have 2 and 1 over 3 and I want to change it into improper fraction, I multiply 2 times 3, 6, plus 1 is 7, and we keep the same denominator. Now if I want to add or subtract two mixed numbers, I have to change them from mixed to improper. How? By multiplying. 8 times 9 is 72, plus 2 is 74 over 9, plus 2 times 12 is 24, plus 7 is 31 over 12. Now how do I add them? I can, because I don't have the same denominator. How do I make them the same? I multiply the 9 by 3 to get 36, and the 9 times 4 to get 36, and 12 times 3 to get 36. And then whenever you have the same denominator, you can add them to get only one improper fraction. The same thing in the subtraction. 8 times 5 is 40, plus 4 is 44 over 5, minus 36 over 10. Now I only multiply by 2, so I get 88 divided by 10 minus 36 divided by 10. So I subtract them easily, and it's 52 over 10. After subtraction, I check if I can reduce. Yes, I can by 2. So I get 26 over 5. And now it's an irreducible fraction. In this exercise, we are going to reduce to obtain an irreducible fraction. So I'm going to start by 2. 20 is divisible by 2, and 40 is divisible by 2. So I can divide both terms by 2. 20 divided by 2 is 10, and 40 divided by 2 is 20. Now I can divide one more time by 2, so I get 5 over 10. I can divide by 2, but I want to check the 5. 5 is divisible by 5, and 10 is divisible by 5. So I obtain 1 over 2, and 1 over 2 is an irreducible fraction. The same steps will be done on the second one, but 25 is not divisible by 2. I try the 3, is not divisible, the 4 is not divisible, and the 5, both of them are divisible by 5, so I get 5 over 10. Now by another 5, so I get 1 over 2, and 1 over 2 is also an irreducible fraction. The last one, I'm going to divide by 2 both terms, so I get 18 over 24 by 2, it's 9 over 12, and now I'm going to divide by 3, so it's 3 over 4, and 3 over 4 is an irreducible fraction. Now let us solve this problem. A family composed of 4 children and 2 adults visited the museum. The child ticket cost 3.75 and the adult ticket cost the double. How much did they pay in all? The first thing I'm going to do is to find the cost of the adult ticket, which is the double of that for the child. So I'm going to multiply 3.75 by 2. Let us do it aside. Times 2. 2 times 5 is 10. 2 times 7 is 14, plus 1 is 15. 2 times 3 is 6, plus 1 is 7. And the point is here. So 7.5 is the adult ticket. Now let us find the total cost of the adult tickets, which is 7.5 times 2 because we have 2 adults, so it's 15. Now I have 4 children, so 4 times 3.75. Let us do it. Then I'm going to add all of them together. 20, 4 times 7 is 28, plus 2 is 30, 4 times 3 is 12, plus 3 is 15, so it's 15. Now let us add the cost of the adult and the cost of the children. 15 plus 15 equals 30.